Hi folks, latest project. My 50-gallon electric hot water heater won't heat water anymore. So as I alluded to in my last video, I needed to find out what the problem was. I did check to see if there was an issue with the breaker. Even though I know typically square D breakers don't fail, sometimes they could on occasion. So I tested that. It wasn't that. I swapped out another breaker for it and tried both of them, and they both work. So that's not the problem. I also know from having tested the old line that there is power coming in. So the issue is in the hot water heater. This was the panel that was on the top there. There was a little green indicator light that was out. And when I pulled the panel off, you can see the black scoring there. Something shorted out here, and even on the inside of the thing you can see that there was no fire or anything, no danger of that. But this electronic circuitry on the top isn't really modular to pull it off, at least not easy. So I can't just say, okay, why don't I just replace this, and possibly it's one of the heating elements went bad. After 20 years, that's not unusual. But because of this electronic stuff too, I'm not going to try to repair. I'm just going to replace. And after 20 years, I figure it's near the end of its normal lifespan anyhow. So we're going to take this out and replace it. Just for your information, an electric hot water heater is generally fed by 10-2 wire. That's for a 30 amp. It has no extra ground. It's got the two hot legs, and then of course the regular bare ground. So I've got that to replace. I mean, I don't have to replace that, just I'll reconnect that. And then the other thing should be relatively simple. You've got these flexible copper connecting kits that I got with this thing when I put it in. If they're still good and they'll still work, I'll just use them. If not, I did get a new kit just in case. Basically, it's just to remove this 3/4 inch nut there, and there's one on this side, of course, too, for the hot water. And you can see the difference between the way it looks, the copper looks when it was exposed and when it wasn't exposed. And that might do the trick. If these are going to be a little too short, I don't know, but I have an 18-inch replacement if need be. So that's what I need to do. What I need to do first, of course, I've disconnected the first thing I did, of course, is turn the breaker off. Got to be safe. And then I disconnected the electrical. I need to turn, I already turned the hot water out. This is the hot water out valve off. And then also the in, the way I have this set up, I have my water main coming up from the expansion tank on the and equipment from the pump. Comes up to here. I have a shut off right there. Then I have my filter, which I'm going to change to sediment filter, and then I have a second valve on the other side. I put the two valves in like this, so if I should have to change out the sediment filter, not just the filter but also the housing, it's easy to just shut the water off from both places. I don't need to drain anything, and then I can go from there. So that's what we'll be doing. We'll shut off the feed, the main feed. The house won't have water for a little while until I put the new hot water heater in. I could have set it up, I suppose, and put another valve right here. That would be the feed. I could turn that valve off, and then I could have left the rest open. But I didn't bother to do that. So it is what it is. So what I was going to do is downsize a bit. This 50-gallon hot water heater did well. I got a good deal on it at Lowe's when I got it some 20 years ago. But now I really don't need the 50 anymore. I was going to go down to a 40. However, I'll show you what I ended up with when I come back to you on this. So that's going to be the plan. Disconnect this, get this out of here. It's full of water. Typically what you would do is there's a drain valve on the bottom. You put a hose to it and let it drain outside. But the problem I'm having now is it's so cold and things. I think if I can just wrestle it off of here, get it on the hand truck, wheel it outside, and then just let it drain from there I'm going to try to do that rather than try to get a hose set up. I just don't want a mess of water everywhere or ice everywhere. So I'll come back to you when I'm in process. Alright, I have disconnected the lines. This one I did from up here because this is really tight. When I get it out of here I can get a better grip on it, but it's disconnected. The water lines in the house are drained as best they're going to drain. I have a sink valve, a sink faucet open here, so there's no water pressure anywhere. And of course I got the old skirting off, the insulation blanket, and I took the tube here for the pressure relief valve that you need to put on. I'll show you when we put the other one on. This is more for people who have hot water heaters that are connected up to city or municipal water supplies where the pressure coming in is a whole lot higher. With a well pump, I'm not really worried about it, the pressure being so much in here that it would explode otherwise. That's what this valve is for. After it gets to a certain pressure, it will open and then relieve some of the pressure in there. I've never had to use one. I always put them on. They actually come with a kit where they're already pre-assembled. You just cut the tube to size. The other thing that often comes with a hot water heater is an aluminum tray that you can put underneath it just to protect floors or whatever in case there be some drips and leaks or what have you. I have never not here, I haven't bothered with it because it's just a concrete floor. If I get some drips, it's no big deal. This was too heavy to really try to wrestle out of here with that much water, and I probably should have known that, and I don't want to take any chances of it tipping and smashing into my expansion tank and the rest of my plumbing here. So what I'm doing is I've opened the valve here on the bottom, and I'm just bailing it out about a gallon or so at a time. Just open the valve, let it, and then I'm throwing it down over here into my slop sink. So when I'm not going to take it all out that way, but when it's light enough that I can manage it, then I'll get it out with the hand truck. So I'll come back to you when we get to that point. I think I've taken out maybe about 15-20 gallons so far, so we'll see where we are. Alright, well, here is my new hot water heater. As you can see, it's an A.O. Smith 100. That's the lower end of the line that Lowe's is now carrying. As I said before, my goal was to scale back from the 50 that I had to a 40 here. But when I walked in the store, I'm walking down the aisle towards where the hot water heaters are, and there's that aisle where they put the scratch and dent appliances and things, and I see this thing sitting there. And if you look here, it says it originally was $529, reduced to $370.30. And I was looking at it like, okay, what's going on? Those wires were exposed, sticking up. It wasn't in a box. And I thought, okay, is this worth taking a chance on? So I managed to get a hold of the guy that works there, and he said, look, what happened was some guy bought this, then he brought it back and said, it doesn't work. Now, they're not supposed to bring them back, they're supposed to call the company, but he did, and Lowe's was willing to refund his money. But the guy told me he did, and he said this is a common mistake that do-it-yourselfers do, is he installed it. He turned the water back on and turned the power on to heat the water. But what he did not do is he didn't open the faucets in the house. And what happened is the water filled this tank partway up, and in the upper chamber here, it was mostly air. And what happened then was when the electricity was added, the lower heating element, you see behind these doors are the two heating elements. The lower heating element worked fine. The upper one was trying to heat air, and it burned out. So he took it apart, pulled the unit out. He showed me the old heating unit. Yes, it was burnt. He said he replaced it with a new one, and he also checked the lower one to make sure that was still good. And then they put it out as a reduced item, still giving the full 6-year warranty for it. So I thought, well, the guy was an older man who had been in the business, I guess, for a number of years, so I figured he knew what he was doing, and it's a chance I'm taking, I realize. But the price, the cheapest 40-gallon low-end A.O. Smith hot water heaters were I think it was $4.29 was the cheapest. So what I ended up doing is I got, almost $60 less for this, plus the unit is 10 gallons bigger and was originally $5.29, $100 more than what I was going to get for a 40 gallon. So hey, I'm not unhappy at all. We'll see how it works. Hopefully he was right and I didn't get ripped off. So what I'm doing here now is I'm getting ready to hook the water lines back up. I was able to use the old, at least I think so. We're going to see after I put pressure to it to make sure there are no leaks, to use the old flexible connectors. Now the thing that you need to remember, and I'll show you this, I haven't fastened this one on yet, is you've got to put your Teflon tape on the threads so that you get a better fit. Just this, you've seen these little things, anybody's done plumbing. And just a reminder, to put it on properly, you wind it clockwise around the threads, unless there's some reverse threads on some project, but typically you wind it clockwise, and that when you're tightening down, it pushes it into the threads rather than pulling it back out. So what I'm going to do is, I have the cold water line tight. I just have to finish doing the hot water line, and then I'm going to turn the water back on, let it fill, and I still have my faucet open, so it can, all the air will push through up and out of this, of course, down the hot water line, and hopefully that's the only hot water faucet that's open in the house, and then that should bleed the tank completely so there's only water in here. You don't want any air, because the heating elements are not made to heat air, they're made to heat water. So we'll see what happens, but I'll come back to you in just a minute. Okay, as you can hear, it's filling. I have the water back on. I also changed out the water filter while I was at it. I don't see any leaks at this point. I have the hot water valve open here. As you can see, there's still lots of air pushing through, which is exactly what I wanted. Get all that air out of there so there's none in the tank. And I'll just keep going until, well, for one thing, I should stop hearing the gurgling once it's full. But we want to get all that air out of there. Remember, it was an empty tank, so it's approximately 50 gallons of air would be in there. I mean, but you want it to all push through. And it is a 50-gallon tank, so it's going to take a little while to fill. But it is running. You can hear the noise the air is making as it's going through the water lines. And I'll show you, I do have pressure with the cold water. Not a whole lot yet because, there we go, now I got some more. But because most of the cold water is going into the tank, it's filling the tank full. So not that there wouldn't be any other pressure in the house, but obviously it's a huge drain on the cold water to fill this. Oh, plumbing's a whole lot of fun. Not too much of a mess at this point. And I think, let's see what I can do here. Here's the old drain tube. And I think that'll work. That's just tall enough. There's no sense, oops, I wasn't even looking at it while I'm trying to film here. Just connect that up. You just hand tighten that. It doesn't need to be real tight. It's just an emergency tube so that if this thing blows, it doesn't spray water everywhere. Some people, I think, would actually take and have this hooked up to a piece of hose on the lower end so that they could drain it out of the house if they had to. So this will just go on there like that. Haven't done the electrical thing yet, but that's not a big deal. I'll show you that in a second. It's just the two wires plus the ground. But and then after I'm sure that it's full of water and I'm sure there are no leaks, I'll turn the power on, and then you just wait. I don't know how many hours it'll take to heat up. I mean, it's a fairly efficient system, but should have hot water this evening. hopefully I won't have any problems with this. I don't see any, I mean there's some water on the floor there from taking the old one out, but the old one, somebody asked me one time, well, what can you do with an old hot water heater? Basically what I've seen some people do, I've heard about, I've never done it, is you can, if you take the plastic or the metal sheet, the sheet metal off, strip it down to just the inner tank, get rid of the insulation, it's still a water tank that doesn't leak. So if you need what they call a tempering tank, if you want to warm up water before you're using it, you can put that in line, say, now I wouldn't probably do so much, well I could do it here if I really wanted to, because the water coming out of the ground is cold. It would fill that tank first before it would go into the hot water heater, so that it wouldn't have to raise it quite as many degrees, so it would save electricity. I could do it that way, but again, you only want it to be in your hot line. You don't want it in your, you want to keep your cold water cold, obviously. Other people who have other types of heat in their house, sometimes older furnaces use a coil in the furnace for the domestic hot water. Same thing, you put a tempering tank next to the furnace. The cold water coming out of the well or the municipal water supply, it warms it up quite a bit before it goes into the furnace to go through the coil to give you hot water in the house, and it's a way to save money. So that's just one thing you can do with an old hot water heater if it doesn't leak, and you take all the insulation off so that the air temperature in the room can affect the water coming out of the ground. So just a thought for you. All right, I'll come back when I'm doing the wiring, and then we'll wrap this. Okay, as you can see, the hot water line is flowing with just water and no air. So I know my tank is full. Now I've also prepped the wiring. This panel came off the top. It's 2 pieces, not a big deal. 3 little quarter inch bolts, nuts, not nuts, machine screws, I guess you could say, but they don't have threads on, or a head on them. I mean, they're, oh, I want to talk about it, just show you. So quarter inch did that. The connections are fairly simple. First of all, through the plate, the wire goes through the plate with my Romex connector there. I got to tighten that down a little bit. They always want to wiggle loose to hold it in place so the wire can't be pulled out of there. Then down in the trough here, you've got your green ground screw. I hope you can see this. Your green ground screw. And then you just loop your bare ground around that. Make sure it's good and tight so that it can't come off. You want to be well grounded. And then you've got your black and white wires coming in from your power source, the 10-2. And here on this particular unit, they have black and red, showing that they're both hot. They're both hot. So I usually put the white with the red and keep the 2 blacks together to avoid confusion. But those are both hot legs, 120 amp, 110 amp, whatever, hot legs to make the 220, 240 volt, whatever it is, for the heater. This particular model is not as deluxe as the one that I had, so it doesn't have an electronic control box on the top. It's just a direct connection, which doesn't matter to me. I don't need all that other stuff. I never used it. And the wires, the connecting wires, are not multi-stranded, which the other ones were, which is again okay. This is just like 12-2 Romex. I don't know why they stepped it down to 12 from 10. I guess at the point of the appliance it's okay to do that. I'm not sure, but it doesn't matter to me. That's what's on it, so that's what I use. I usually want to make sure my connections are good and tight, so I don't just rely on the pressure of a wire nut to hold them in place. I usually will take my lineman's pliers and twist them so that they're connected before I even put the wire nuts on. And then after I secure the wire nuts tight, I will also take some electrical tape and tape around the wire nut and the wire bundle itself to make sure that it's not going to in any way come loose. It can't come loose, and there'd be no possibility of sparks or anything. It's just an overkill habit I've had since I learned to do wiring back in the 80s. Maybe they don't do it anymore, I don't know. I do the same thing when I'm putting in switches and receptacles. I put tape around where the hot screws are, so that nobody could accidentally stick a finger into a box, or even if somebody was, using a screwdriver to do some work, they wouldn't actually short anything out. So again, it doesn't have to be done, but that's just something I do. So all I've got to do is put my wire nuts on, put the cap back on, and then I'm ready to fire up the electrical components of this. And I probably won't know for a few hours how well it's working, because obviously to heat 50 gallons of water is going to take a while, even though this is a 4500 watt water heater, so it's got some oomph to it. But we'll see how it goes. And well, I'll just wrap up the video at this point. It's dragged on long enough. So I appreciate you watching. Thank you for your support. Thank you for liking, subscribing, doing what you need to do. You know the drill, as we survive out in the country and thrive on a shoestring.